So this exercise is related to the particle physics and the accelerators MCQs, and I'll discuss the doubts related to this exercise. First is question number 3. In question 3, positron and muon travel at the same speed through a magnetic field, and the direction of a magnetic field is into. So, which of the following diagram best represents the motion of the particle? So how you can identify first using a left hand rule, you have to identify the direction of the deflection. So according, if we apply the left hand rule, the index finger or the first finger should point in the direction of a magnetic field. So in this case, the magnetic field is into. So the index finger should point into. The second finger represents the direction of the particle. So the particle is going, both of the particles going up, and we have positron is a positive one and muon is a negative one. So when we apply, like with that index finger is pointing into the screen and second finger is pointing up. So where your thumb is pointing towards the left hand side. Thumb shows the direction of the deflection. So that your thumb is pointing toward the left hand side, so means the positive particle should go left. So here, why A and B are totally wrong? Because the positive particle is reflected towards right. So we are left with C and D. So either C can be an answer or D, because both cases the positive particle is moving towards left. And when we compare because the one which is having a higher momentum will have a greater radius of a curvature, or it will, like, deviation will be smaller as compared to a particle which is lighter. So lighter particle, it will deflect more in a magnetic field, or a particle with a smaller mass to charge ratio will deflect more. So positron is having a smaller mass to charge ratio than muon, or it has a smaller momentum than muon. So muon deflection will be first, because they have opposite charge, so it will be opposite. And the second thing, the deviation of a muon will be smaller as compared to that of positron. That's why option C is the right answer. Is it clear, this one? Next is question 12. In question 12, the photograph shows a track of a positron in a particle track, and there's a magnetic field which is perpendicular. So which of the following is not correct? First thing, what will happen as a particle, you should identify the direction of motion of particle. As the radius of a track is decreasing, it is causing an ionization or losing its energy or the speed. So as a result, the radius of the curvature of a track will decrease. So that's how the particle is traveling. So we have to identify which of the following statement is not correct. The energy of the positron is decreasing. That's correct, because the radius of a curvature is also decreasing. The magnetic field act into. For example, if we apply the left hand rule, our index finger or first finger should point into. If the magnetic field is into, so our first finger point into. Your second finger should point in a direction of a positron. So which direction positron is entering? Positron is entering in this direction. And your thumb will represent the left hand. You have to use a left hand. So your thumb will represent the force. So which direction, when you apply the rule, index finger is pointing into and second is representing direction of the particle. So thumb is pointing towards the center in this way. So means the magnetic field is into. Because if the magnetic field was out, then how the particle should move? It should move other way around. But because the magnetic field is in, so it is correct in terms of in magnetic field in. The positron is gaining mass. If the positron was gaining mass or a momentum, then the track should become thicker. So as its speed, usually when the particle travel closer to speed of a light, the mass increase, the relativistic effect, so the mass will increase. But because the particle is losing energy or it is slowing down, so its mass won't increase. Its mass will be constant, same. So statement C is not correct. What about D? The speed of a positron is decreasing, so that is also correct. So statement A, B, and D are correct, where C is the wrong statement. Is it clear, this one? First question number 12, then question 31. So this question is related to the probing a matter. We can use electron beam to probe a matter. So when a beam of high energy electrons is directed at a sample of a material, diffraction occurs. So if diffraction occurs, what does it mean? It means that this electron is not acting like a particle, it is acting like a wave. And these examples are the wave fronts. So when it passes through, a diffraction happens. And why the diffraction happen? The wavelength associated with this beam of electron matches with the spacing between the particle. That's why the diffraction pattern is observed. This can be observed on the set of a concentric circles on the fluorescent screen. Which of the following change would decrease the diameter of the circle? If we want to decrease the diameter of the circle, like we want the circle here, these circles, we want to reduce their diameters. We want them to be closer to each other. So use crystals with a smaller spacing between the layers. Look, reducing a diffraction, like if it is having a maximum diffraction, like if the wave is diffracting more, maximum diffraction is there, then as a result, what will happen? The spacing between the circles when you observe on the screen will be larger. But if it is having a minimum diffraction, if you reduce the diffraction, then the spacing less diffraction, so the circles these will be closer to each other. So use crystals with a smaller spacing. If you use a small, because, and remember, like wavelength, if wavelength is equals to the spacing, then we'll have a maximum diffraction. And here, if wavelength is less than the spacing or spacing is larger, then we have a minimum diffraction. So use crystals with a smaller spacing. If you use a crystal with a smaller spacing, like if the wavelength is longer and the spacing is smaller, again, it will have a maximum diffraction. So this maximize the diffraction, not minimize. We want to minimize the direction, so the diffraction, so the circles will be closer to each other. Use a screen further from the crystal. So if we move the screen further from the crystal, the spacing between the crystals will also increase. Use electron with a greater momentum. Now what will happen? We have the formula, the wavelength associated with the electron, lambda is equals to h over p. So if we increase the speed or the momentum, the wavelength becomes smaller. And if the wavelength is smaller and the spacing is more, as a result, we have a minimum diffraction. So this will reduce the spacing between the circles. And use electron with a lower speed. If we use electron with a lower speed, we have the formula lambda is equals to h over p or mv. If the speed is smaller, the momentum will be small. If a momentum is small, the wavelength will be longer, and longer wavelength diffract more than shorter wavelength. So option C is right. If we use electron with a greater momentum, the wavelength associated with this electron will be shorter. As a result, the diffraction will be minimum. So longer waves diffract more than the shorter waves. This was question number 31. Then question 40. In question 40, the diagram shows a track of the particle. The diagram shows a track from an event at point P in a bubble chamber, and there's a uniform magnetic field into. So if the magnetic field is into, so our first finger represents the magnetic field, which was into. The second finger represents the direction of the particle, which is going up here. And thumb represent the direction of the reflection. So your thumb is pointing towards the left hand side. So the positive particle will move towards left and the negative particle will move towards right. And the one which is having a smaller radius of a curvature means it has a smaller momentum. The one which is having a larger radius of a curvature will have a greater momentum. So which of the following is the reason why the track cannot be represented as a proton and anti-proton pair? Like proton and anti-proton, which are having equal kinetic energy, so the radius of the track should be equal. Like if there was a proton and anti-proton, then this radius of a curvature should be equal. The curvature is perpendicular to magnetic field, but this is uh, right. The track is perpendicular to magnetic field, but that does not give a reason why this cannot represent a proton and anti-proton. Track curves in different direction, that's also true, but this is not giving an explanation. If proton and antiprotons are there, the track must be in opposite direction, and here the tracks are in opposite direction. The tracks have different curvature. Because the tracks have different curvature, if we have a proton and antiproton, if they have the same kinetic energy, then the curvature should be same. So if this is a proton, this should be antiproton. Because they have the same kinetic energy means they will have the same momentum. And if they have the same momentum, the curvature of the track should also be same. So there is no track before point P. Before point P, if there is no track, but that it may be a neutral particle dissociate, but this does not give an idea that it should be proton or antiproton. It might be electron or positron. Like it can be any antiparticle, but presence of a no track at point P does not indicate that there must be a proton and antiproton. It can be any particle and antiparticle which formed by this neutral particle. So why C is correct? Because the tracks have the different curvatures. If it was a track of the particle and antiparticle, and with the same kinetic energy, the track must have the same curvatures. Is it clear? Question 40. Next is so this was question number 40. Next is question 42. Then 44. A proton enters the magnetic field. It has a velocity v perpendicular to magnetic field. The diagram shows a path taken by a proton. An alpha particle enters the magnetic field at the same point as a proton with a velocity v, at which point A, B, C, D is the alpha particle most likely to leave the magnetic field. So this one is for proton. An alpha particle enters the same point also with the same velocity, but an alpha particle is having more mass. Like example, a proton mass is m and its velocity is v, so momentum is mv. But for alpha particle, which is also a helium nuclei, the mass will be 4m, the velocity, even though it's v, so the momentum should be 4 times. So if it is having a higher momentum, as a result, deviation, like it will have a greater radius of a curvature or smaller deviation. So if this is for proton is there, but alpha particle, both have the same charge. If both have the same charge, they will deflect in the same direction. But because alpha particles are having a more mass, so greater momentum, so as a result, when alpha particle will enter, it will deviate less or it will have a greater radius of a curvature. Smaller deviation means greater radius of a curvature. So this is for alpha particle. So C should be the right answer. If they ask if there's an electron enter, if there's an electron enter, or example, a positron enter. So if a positron or electrons, they are lighter than proton. So in that case, it will have a greater deviation in the same direction. Why same direction? Because they all are positive. And why different deviation? Because they have different momentums or different. If the speed is same, the mass is different, so the momentum will also be different. The one which is having a higher momentum will deviate less, and the one which is having a lower momentum will deviate more. Is it clear? So this was question number 42. Then we have 44. A positron enter a particle accelerator and it emerged out with a mass 3.8 into 10 power. So it can be concluded that, look, what is the mass of a electron or a positron? Not proton, it's a positron. So this is a sign for positron. So what is their mass? It is 1.6 into 10 power minus 27 kg. Sorry, 9.1, that 1.6 exponent minus 27 is for neutron and proton. This is 9.11 into 10 power minus 31 kg. But this is a rest mass, like when they are stationary or they are moving at not close to speed of light, the mass is constant. But you can see here, when it is coming out, this is a higher value. It means the mass of positron has increased. So if the mass of a particle is increased, then what is the relativistic effect? Relativistic effect state that when particle travel closer to speed of a light, their mass does not remain constant, their mass increases. So it means because the mass has increased, so it means that it is traveling close to speed of a light. That's why the mass has increased. So rest mass means like particle mass when it is moving at a low speed or when it is at rest. And relativistic mass means when the particles travel close to speed of light for any particle, even it's a proton, neutron, electron, the mass does not remain constant, it increases. And question number 45. What is the direction of this is an anti-proton. Anti-proton means like negative particle is there. So we'll apply the left hand rule and check what will happen. Like anti-proton means negative particle. If we consider magnetic field is into. So if the magnetic field is into, you will use the left hand rule. Your index finger, your first finger should point in the direction of a magnetic field. which is in this example we took into. Your second finger represent the direction of the particle which is moving towards the right hand side, and your thumb represent the direction of the force on the particle. So when you apply the left hand rule, means if this was a positive particle, it should go here, this direction. But because it's a negative particle, it is moving in opposite direction. So it means this is correct, because when we apply the left hand rule is for the positive particle. If it's a negative particle, it will move opposite to the positive particle. So first, if we consider if there was a proton, it will go up. But because this is anti-proton, so it will go in opposite direction. So when we apply the magnetic field is into, we got the same result. Like it shows that the magnetic field is into, because if magnetic field is into, the proton will deflect top of the page. So the anti-proton, yes, you can also use a right hand rule for the negative particle. If the particle is negative, instead of left, you use your right. And if the particle is positive, you use your left. It will give the same idea. With the left hand rule, when you use a left hand for a negative particle, you have to take direction opposite. But if you directly use a right hand, you don't have to make it opposite. It will give the same direction. So this was question 45. Then we have question 49. In a particle physics, often the mass is given in giga electron volt per c square. If the particle have the mass m in kilogram, its mass in giga electron volt. So like if we want to convert, usually this is what happen. If we have the mass in kilogram, we should be able to convert into giga electron volt or mega electron volt. How to convert the mass in kilogram into giga electron volt? Or so we have the formula E is equals to mc square. So when we use this formula E is equals to mc square, so mass of the particle is m and the speed of a light is c square. So actually it's like getting the energy. And if I want like E is equals to mc square till this point, but that will be in joules. We want to convert into giga electron volt. So how we can convert into giga electron volt? So first we have to convert into electron volt. How to convert the joules into electron volt? We multiply by 1.6 into 10 to the power minus 19. One electron volt is equals to 1.6 into 10 to the power minus 90. As not multiply, divide, because we want to convert joule into electron volt. So we divide by 1.6 into 10 to the power minus 19. So when we divide by 1.6 exponent minus 19, which is also known as a charge of electron, so we got mc square over E. Now this answer is in giga electron volt. But the giga electron volt, sorry, this answer is in electron volt. We want to convert electron volt into giga electron volt. So if you want to convert into giga electron volt into giga electron volt, what we do, we divide it by 10 raised to the power 9. So this will become mc square over E into 10 to the power 9. So mc square over E 10 to the power 9. So it matches with option D. So actually what we did, we have the mass in kilogram. When we use the formula, we get the energy in joules. Then that energy in joules, we divided by the 1.6 exponent minus 19, which is also known as the charge of one electron. We got the answer in electron volt. And this electron volt, we divided by 10 power. If we want to convert into mega, we divided by 1 million or 10 power 6. But if you want to convert into giga, we divided by 10 power 9. So D will be the right answer. Is it clear? So the idea is that the mass in giga electron volt per c square is same as energy in giga electron volt. Like if I get 900 into giga electron volt per c square is a mass. So how much energy will be there? It will be 900 into giga electron volt. That's why we convert the mass into energy, and the energy in giga electron volt is same as the mass in giga electron volt per c square. Is it clear, this one? Then question 51. A repeated question is there. This why we cannot say this is a track of a proton and anti-proton pair, because the tracks have different curvatures. If it was a particle and anti-particle, the track must have the same curvatures. So the tracks have different curvature. That's why this is not correct. So this was the particle physics MCQs. Anyone else, in case if I miss your doubt in particle physics?